Yes, dear students, today we are going to learn a concept called as IP subnetting. Now, before going to look at the topic, what do you mean by subnetting? Subnetting means if we have a bigger network, we are dividing it to smaller network as per our requirement. So, as per our requirement. So, first question comes here is, why do we do subnetting? Why do we do subnetting? Why do we do subnetting? Because there are drawbacks of classless addressing system, classful and classless addressing systems. So the first drawback of classful addressing system is we have wastage of IP addresses. You may ask me question, how do you do? So if you take a class A address, in a class A address the total number of given hosts is 2 raised to power 24, and this value is greater than almost or equal to some 1 crore or more than 1 crore of host devices. So if you take any bigger organization, any large organization, so we may not find these many number of hosts where one class A address can be given to it. So whatever all the remaining addresses in that particular class A address, host addresses, all will be wasted. Now let us take, if you tell me that you can take class B. Now if you take as class B, you have number of host devices is equal to 2 raised to power 16, that is 65,535 hosts, and this also a very big number where now some organizations may have this many number of hosts, but majority of the cases here also lot of addresses are wasted. Now let us take, you can ask a question that we can go with the class C. When you go with the class C address, here the number of host addresses, host IDs is 2 raised to power 8, and this is equal to 256, and this is very smaller number, and we are not able to use that. So it is very difficult for us to if we go to class C, it is difficult for us to accommodate more number of devices. If we go for class A and class B, there are many cases in which we are unable to allocate all the IP addresses to the host. So to avoid this thing, we are going to the concept called as subnetting. And the second main issue of going to subnetting is maintenance. Maintenance means, you may ask me a question. Suppose let us take, I have a bigger network, one network is there, and let us suppose I have some 1,000 number of hosts in this network. So if I have 1,000 number of hosts in this network, there are so I will have some 1,000 user IDs and 1,000 passwords are there, and if I take, if it will be difficult for a single person to maintain the records of the 1,000 users and 1,000 users. So what we will do is we have to divide the network and we will give it to it. Not only this, let us take go for an example that we are having some educational organization. So let us take an educational organization such as let us take a Chaitanya school, right? So this Chaitanya school is having so many, so we'll take one school. So in a school we have so many departments, like one is an exam section, one is a faculty section, and one is like a student section, and one is like a class section, and like other someone belonging to maintenance. So each one person, there may be a lot of people will be there, and all will be pertaining to each one department. That means if you have a Chaitanya school or any other thing is having one network, the whole network, if they are using, so all people will be using, let us say I have some 1,000 hosts in it, so all the 1,000 hosts will be in the single network. It will be difficult. So what I will do, I will divide this network. One set I will give to exam section, other I will give to faculty section, other I will give to like class student section, and other I will give to some maintenance section, and like that. If I do it, it will be easy for the people to handle the network, and also easy for the people to communicate between them. So this is one more advantage we have. And the third is when we are using this IP addressing, when we are using this subnetting, and we are using and if we are using a larger network, these larger networks are more prone to errors. So when a small networks are there, they are less prone to errors because of less number of devices, and collision also will not occur between we can look at that congestion will not happen in the network, and so errors can be reduced. So we have we have three advantages of doing subnetting. One is one, we avoid wastage of IP addresses to the host. Second is easier maintenance, and three, network will be less prone to errors. So these are the three benefits because of which we are going to a concept called as we are going to a concept called as subnetting. So today we will see how do we divide a network into different networks. Now let us take the heading subnetting. So to understand this concept, I am taking a class C address. So the class C address starts from 192 to 223. The first octet of the IP address will start from 192 to 223. So I am taking an IP address 196.16.24.0. Let us take this network. So if you take a class C address, in this first three octets come to network ID, and the last octet belongs to host ID. So the number of possible hosts in this network is 2 raised to power 8, that is 256. Now let us see how this, let us have an idea of this network. So you have a network like this, and this network is represented by 196.16.24.0. so this, the outer line which you are seeing here, this is represented by a number called as 196.16.24.0 to the outer internet called as www. So to all the internet, this network is represented by the IP address 196.16.24.0. Yes, now we have what we have. We have a network. This network is having 196.16.24.0, and we have a router over here. To this router, from the external network, that is your www, that is your internet, from here the packets reach to the router, and from this router the packets reach to the network. Now let us see this process from the beginning. So how this router will identify that whatever the packet is coming in here has to be routed to 196.16.24.0. How it will do is, we have a concept called as default mask. So what is the default mask for your class C? This is 255.255.255.0. So if you look at this IP address, 2 raised to power 8 means 8 bits are there. When you place all ones in all the 8 positions, then the total number, when you convert into decimal, it comes to 255, right? So now what will happen? The router will perform an operation with 196.16.24.0 to 255.255.255.0. Now I cannot take a network. I will have only like a host ID. Let us assume that I have a host ID. I have a host ID 24.18 I have to move, and this is 255.0. This is the host ID which is there in this network, and I have to move to that one. So the packet with an IP address 196.16.24.18 has reached to the router, and now what router will do? Router will perform AND operation with the IP address of default mask, that is the 255.255.255.0 to the given IP address. So when you perform AND operation, 255 means all ones. That means if you multiply binary with 1, whatever the number is there, that number you will get. That means here you will get 196, you will get 16, you will get 24, and the last 8 bits anyway are zeros. If you multiply with 0, you will get 0, then you will get 0. Now this will be your network. Now the router will check its IP address table. In that it will find that this network is on so and so interface. Let us say that is on an interface gigabit Ethernet port 0 bar 0 bar 2. It will identify it and put the packet onto the interface, and it forwards the packet to the network. Now we want, what we want to do, we want to divide this network. So we want to divide this network. So how to divide this network? Now first of all, we should not touch the bits which pertain to the network address. We should not touch this bit, we should not change this bit. Why? Because if we change any one bit in the network address, the total network address will be changed. That means we want to reach Delhi, but we will reach Chennai. So this is wrong, and we should not touch the network bits. Now what are remaining? We have only network bits. How many network bits you have? I have only 8 network bits. So now what I will do? Now, so now I am unlocking all the 8 bits. So I am not touching this first 3 octets. So 192.6.16.24. will be like that. So the last 8 bits 1. So okay, wait. Before dot. So 1, 2, 3, 4, 5, 6, 7, 8 you have, and also I'll write 196.16.24.1, 2, 3, 4, 5, 6, 7, 8. Now see, you have 8 bits. In this 8 bits, if you want to divide a network, what we have to do, we'll fix the first bit. This first bit in this first octet will fix. These bits are binary bits, so we have 2 options here. So first time we'll fix it to 0, and the second time we'll fix it to 1. Now we are fixing these bits. Once you fix this bits to 0, now we write 196.16.24.00000 4 zeros, 5, 6, 7, 8 zeros. So this will be the first network address. Then it will come 1, then it will come 0, 1, 0, then it will come 0, 1, 1, then 1, 0, like that it will go on. Now when you look at this, it will come from 196.16.24.0, 1, 2, and then go on to 196.16.24.0, 1, 2, 3, 4, 5, 6, 7. So this number is 127. So the first set of IP address now come to be 196.16.24.0 to 196.16.24.127. Now look at here, we have fixed the first bit to 0, then we'll write all zeros here, 0, 0, 0, 0, 0, 0. Now what is this number? This is 128. Now we started 128, next is 129, 130, and we go on, it will go up to 255, that is 196.16.24.255. Now this will be the second set of IP addresses. So if you take it as subnet 1 and this is subnet 2. Now subnet 2 is having an IP address starting from 192.16.24.128 and it ends at 192.16.24.255, and subnet 1 will start from 196.16.24.0 and it ends at 196.16.24.127. Now look at here, we have given a network address 196.16.24.0. This IP address cannot be, the IP address 196.16.24.0 cannot be assigned to any host. Why it cannot be assigned to any host? Because it is representing your network, so it cannot be assigned. So the first IP address in subnet 1 is 196.16.24.18 and going up to last up to 196.16.24.127. Similarly, in a second subnet, we have one starting from 196.16.24.128 and is ending up to 196.16.24.255. Now this 255 is called as a direct broadcast address, and we cannot use this address to any host. So what is the possible number of usable hosts? When you look at the figure here, you can understand that we have 2 power 8, that is 256. We have 256. Out of that, we are not using 2. What are they? One is 116, 196.16.24.0 and other one is 196.16.24.255. so if you remove these two hosts, then so 256 minus 2 is equal to 254 is a possible number of usable hosts in this network. So this is how a network is divided into two subnets. Now you can ask me a question. Now, when I want, how can I identify to move from subnet 1 to subnet 2? To do that, we have a router. We should have a router over here, and this router should have a concept called as subnet mask. We'll have subnet mask. Now, what is this subnet mask? Now, how we are going to calculate this subnet mask? So, how do you take the subnet mask is, right. So, for that, what we will do is whatever the number of bits you have fixed, make them all ones. So what we will do? So when you take how many are fixed, network address bits, that is your 24 bits are fixed. Along with that, one more bit in the last octet is also fixed. So 24 bits means what you'll have, that is first octet is 255, next octet is 255, next octet comes to 255. Anyway, all bits are ones. In the last octet you'll have one fixed bit is 1. Now 1, 2, 3, 4, 5, that is 5, 6, 7, 8. This number turning up to 128. So your subnet mask will turn up to 255.255.255.128. Now you may ask me a question, how do we know that it is going to give you, it will tell you whether it is going, whether it can divert to subnet 1 and subnet 2. Now let us take an IP address and perform the AND operation with the subnet mask. Let us take an IP address 196.16.24.8 I want to take. So we want to perform the AND operation with the subnet mask, that is your 255.255.255.128. Now anyway, this is 255, this is 255, this is 255. When you perform AND operation, we'll get 196.16.24 will be the same, and we'll see the AND operation for the last bits. Now if you want to write 8 means 1, 2, 3, 4, 1, 000. And what is 128? 1, 0, 0, 0. 0, 0, 0, 0. Now perform the AND operation, will have 0, 0, 0, 0, 0. Now if you look at the first bit, it is 0. If it is first bit is 0, it will divert it to subnet 1. Now let us take another IP address for the subnet 2, 196.16.24.130. Right, 130. And now I want to perform the AND operation by using the subnet mask. What is that? That is 255.255.255.128. Now what is 130? So anyway, 128 is 1 over here, 1, 2, 3, then 0, 0, 1, 0, it is 130. So 128 is 1, 0, 0, 0, 0, 0, 0, 0. Now perform the AND operation. What you'll have? 0, 0, 0, 0, 0, 0, and you'll have 1 over here. Looking at this bit, it is 1. It will understand that this you have to route to subnet 2. This is how a router will route the packets, a router which is connected in between these two subnets will route your packets to subnet 1 and subnet 2. This is called as fixed length subnetting in classful addressing. Now in this, what probable questions you can have? What probable questions you can have means, you will be asked, like the question will be asked, the questions may be asked like I have a company is having a company is having a network called now let us take a question like this. Now how to take a question? I'll show you how to take a question. A network given, a network of 192.18.36.48. I want to, so a host ID is given in a network. Let us take, so like I'll frame the question. Let us assume we want to communicate to a network, to a host ID 192.18.36.48, right? The given network is divided into two parts using fixed length subnetting. Let us find out the total number of hosts in each subnet. This is one such question, or otherwise they will ask like divide the network, having divide the network using fixed length subnetting, having a host ID of 194.38.56.126, right? They will ask a question like that. Now at this time what we have to do, we have to first of all find out the network ID. Then after finding out the network ID, we have to divide the network into two parts. We have to find out the subnet mask, and we have to give the total number of usable hosts in subnet 1 and also the total number of usable hosts in subnet 2. We have to identify the direct broadcast address, and they have to be listed down as shown in this here. So what is the total number of usable hosts now? So 254 divided by 2, how much it comes down to? 127. So each subnet will have a number of usable hosts of 127, right? This is how in classful fixed length subnetting is done in classful networks. Thank you.